All right, friends, let's get out 11G. 11G.
Can you sign this? I'm not going to be here tomorrow because our meeting starts at 1:29 in the afternoon. I'm going to grab it. We're going up. Should be good enough for like this period.
All right, anyone not here?
Ben.
Where's Ben?
He's sick.
No way. Is that it?
Hey, I don't understand how we're going to have like a super long meeting tomorrow.
All right. So, let's get through our homework. Fortunately, what I find is interesting about this chapter, and maybe you disagree with me, but of all the concepts I've taught, and I know there's a lot of stuff that I've taught quickly, but this stuff, we're taking our own sweet time on it. It's like, okay, here, dedicate this whole chapter to asymptotes when it looks like this. And I'm like, what the? But I guess it's great. So E, F, G. G, right? And it was the evens?
Yes.
All right. All right, on that first page. Okay. Evens. 6. That's a good even number. Number 6.
Do we start the test tomorrow?
Wait, we have a test tomorrow?
Quiz tomorrow?
Nah, it's Monday, isn't it?
We're behind.
Yeah.
They moved
Wait,
Friday.
It's Tuesday now.
I guess so.
It's that Thursday?
We do?
I am so out of mood. And tomorrow,
I'm just freaking out over here.
We should have one day where we just like.
It's called Yesterday, Gypsy.
Yeah. Gypsy.
All right. So let's see. Let's find our vertical asymptote first.
Is it G? H.
We're on G right now.
Alright, cool.
So for vertical asymptote, so I set that equal to 0. So I get x equals half. So
Did we need to find the extra points?
yeah, I mean, there's 2 that you really should find.
Okay, so they wanted us to find extra points.
Okay, no, you're all right. Horizontal asymptote. So I look here, the degree here and the degree here are both to the first. So I'm going to get y is equal to also half because it's the lead coefficients of this and this. Is that all right? So this will indeed have a x-axis crossing and a y-axis crossing. There's no real strange negatives up in the numerator with the x or anything. So basically it's going to look like this. And then let's try and decipher a handful of points. All right, so we'll look for any roots first. So should be just 1. So I'll plug 0 in for y. If I plug 0 in for y, multiply this side times 0, I get 0 equals x plus 1, so I get -1. Is that okay? And then, I don't know why I made that there. I'm so sorry. -1 here. -1 comma 0. And then if I want to find my y-intercept. So then I'm going to plug 0 in for x. So I get 1 over, so I get -1. There we go.
Hey, you think Iron Man's in the death metal? Because he's Iron Man.
Sam, sometimes the filter just needs to stop at the mouth.
Yeah.
All right, and no, I don't anticipate you guys finding extra points. I mean, seriously, when you start plugging values in, you just wind up with fractions. You're like, oh, look, this is 3/5. Great. Anything else on the homework you want to take a look at? Any page.
2.
2? Flip that bastard. Ooh, good one. Okay, so I'm going to write number 2. I'm going to do this. Are you okay with that, first of all, that I move that negative just up to the top? Is that cool?
Yeah.
All right, so that means it's going to kind of flip over. And see, math, graph, Cartesian.
Is a vertical asymptote -2?
I don't know, I haven't gotten there yet. So a vertical asymptote is equal to x plus 7 equals 0, so x equals -7. So you were off a little bit there, buddy.
The horizontal ones.
Oh, the horizontal, okay. Zoom in. Alright. So -7 is like here. Is that okay? And then horizontal asymptote is going to be this degree and this degree are the same, so it'll be lead coefficient over lead coefficient. So y equals -2/1, which is -2. And notice my graph is counting by 2's. Then, what's up, YouTube? So normally it's here and here, but because I have that negative, it's going to go like this and this. Is that okay so far?
That's alright.
All right. So let's figure out where it crosses from the roots. So I'm going to plug 0 in for y. If I plug 0 in for y, that moves over, so I get 0 equals -2x, so 0, 0. Wait a minute. Did I just do that wrong? Hang on. Why is this wrong?
Are they gonna add more days of
No. Okay, I'm messed up on my graph. Hang on, let me just find the y-intercept real quick. Y-intercept plugs 0 in, so I get -1/7. 0, -1/7 is like here. I got a big question mark on that one. It's not doing what I wanted it to do. So just put a question mark on it. What else? Anything else? One more. 12, you got it. 10 wasn't the thing? Alright, number 12. Alright. Alright, vertical asymptote is at x equals -3. Horizontal asymptote, too much chatting over there. So my highest exponent is 1 and 1, both here and here, so I'm going to go -2/1, so I get -2, so y equals -2. And then let's just figure out some points. So where it crosses our roots, I'm going to plug 0 in for my y value. So if I move this over, it becomes 0, so I get 0 equals 1 minus 2x, so -1 equals 2x, -2x, so x equals half. So I get half comma right there. Ew, okay. And then, what's my last one I want? Y-intercept. So I'm going to plug 0 in for x. So I get 1/3. So I'd say we're looking about like that. So I think it's better if we plot our roots and our thing to get the rest of our graph.
He has a guaranteed spot.
All right, make sure your name's on that. Pass it on up, please. A reminder, friends. There is the Schoology thing, and some of you still need to finish your quiz up with me. Yes.
You better have a super slender.
For tomorrow, what are we gonna be doing? Like, could I?
So,
could
I am not proctoring, so if you...
Because I can
So-
make up the quiz.
Yeah, so hey, my friends, I'm not proctoring, so I'll be in my office.
Oh, really?
Yeah, so text me before you come just to make sure. But I would say I have zero problem if a student were to come in and finish up some stuff.
Yeah, I might do that.
Yeah, turn it in G. But text me before you come because I gotta make sure you can get in the building because there might be some weird wackadoodle rules going. No one can come into the school unless they're testing. Which is like,
I got out of the secure perimeter.
did you?
Actually?
Yeah,
I felt that
I was in
for
bad.
like
What happens if some kid is at like kid super when they go in?
Nope, you can't. Say, I'm walking back on campus and you go back to where you came from.
And also,
Yeah.
like,
Was she here?
I don't want to be here, but I'm just kicked out. Okay. What do you do?
Some lady was doing
Homework? And homework.
This lady told me and Adam to sit down against the wall and
Homework?
laughing at her and walking.
Homework?
What are you talking about?
And over here. Ferb.
And sulfite cases. Sorry.
Okay.
Alright.
Sulfite.
You skip for a second.
No.
You
know what I'm talking
No way.
Do you want it to be?
Yeah.
It's so dark.
Do I need to sign up for the medical?
That's fun, actually.
I don't know, man.
Did you
Next
Yeah, because
year?
it's-
Those were pledged.
Did you sign up pre-registered?
Yeah, I did.
Yeah, it should be good.
So, because my friend told me that if it doesn't work if you pre-reg this year, you have to do.
Do you have tape?
It changes.
I'm in it.
I'll be back.
I have some absent work.
You're gonna
So
do
not.
Too many.
You're gonna expect me to use this? And that's supposed to be invisible tape, but not actually invisible.
So I don't have it. Sorry. Alright. Notes. Pretty quick, pretty easy, I think. Let's see how bad your teacher can screw it up. Alright. So we've talked about vertical asymptotes, we've talked about horizontal asymptotes. So we're gonna have one last one when it changes the horizontal asymptote a little bit.
Diagonal asymptote.
Not there yet. We'll get there. All right. So, these are all characteristics. When you look at it, going, "What the heck is A supposed to be?" Whatever. Bowling pin 'em. All right. So, I think you're all set finding the domain. I think you're all set finding how the denominator is 0 to find the vertical asymptote. The horizontal asymptote, there's basically 3 properties that are going to work. And I'm just going to move on until we get to the properties. So this one. So I just have a number on top. So let's take a look real quick. Just figure out roots on this one. What? All right.
Grant, how did you get here? Is it in here? It's in here, bro. When do you come to class?
Who needs one?
No, it's not, Cooper.
Sorry about that.
Did you see my messages to you in the
I
video?
really got you.
All right. So, so vertical asymptote. What do you think? X is equal to 0. Agree? What makes the denominator 0? 0. So I get a vertical asymptote here. So if this happens, that means I don't have a y-intercept. Horizontal asymptote. So I just have a denominator. 3. What do you think? Horizontal asymptote. So think about it. If I start plugging numbers in, if I start plugging like 1 and 2 and 3 and 4 in, I'd get 3 over 1, 3 over 4, 3 over 9. 0. If I got, and I keep going, so that's basically doing something like this. It's saying, hey, I can't cross here, so y has to equal 0 as well. in this case, do we have roots?
No.
No. And you can look at it and say, well, it should be obvious that I can't have roots, because if I plug 0 in for y, I'm going to get 0 equals 3 over x squared. If I multiply this over here, I get 0 times x squared equals 3. And even my kids in Algebra 1 are nailing that, saying, well, that means 0 equals 3, which is the best kept secret in math. We had no idea. Anytime I have a 0, I can plug a 3 in. So there aren't any. Y-intercepts, same idea. If I plug 0 in for my x value, I'd get undefined. So there's no intercepts there. If I were to look at what my graph actually looked like, it would be this and this, with a domain of negative infinity to 0 and from 0 to infinity, and then additional points. I don't see a whole lot of work by you plugging in extra points. Okay, you start at 0, it's not going to happen. You start at 1. I mean, if you wanted really to do this, and this is the only one I'll do it on because it's a simpler one to plug into. If I did like -2, -1, 0, 1, 2, 3, 4, if I plug -2 in, I'd get, I'd wind up with 3 over 4. If I plugged -1 in, I would wind up with 3. 0 doesn't work. 1, I get 3. 2, I get 9. Now we're going the wrong way. 3, I get 1/3. Why did I do that? Why did I get a 9 there? If I plug 1, If I plug 1 in, I get 3. If I plug 2 in, I get 3/4. I'm so happy I can do math. And so on and so forth. So are those extra values really helping you? No, it's just saying that, hey, we're getting closer and closer and closer to the x-axis.
If you had a different number on top, but there was no x on top, would it still be like the
0.
exact same graph?
0. Yeah.
Okay.
I mean, it stretches vertically, but that's not like the wonderful thing in math going, hey, look at this. It's like, graph looks like this. This one looks like this. What's that one? Looks like this. They all look the same. They move up, they shift, they stretch a little bit, but that's about it. All right, and then we get to this one. Now we have a grouped quantity, and then we have this negative sign. So think about our vertical asymptote. Our vertical asymptote, I have this.
Can you just move the negative to make it -4 on top there?
Yeah. So is that what the denominator is? If I multiply that out? Yeah. So vertical asymptote, degree on top is less than degree on bottom. So in this case, I have x minus 2 equals 0, so x is equal to 2. And it's one of those double roots. But what does that mean as far as an asymptote goes? I don't think anything right now. I'm sure somewhere in math it's going to mean the world, but right now it's going to be that. So my vertical asymptote, x equals 2, even though it happens twice as a double root, I think it's still fine. My horizontal asymptote, my degree on top is less than my degree on bottom, so y equals 0. And then, do we have any roots? Well, no. We don't have any roots because y equals 0. Do we have a y-intercept? Yeah, we have a y-intercept. Why do we have a y-intercept? Because the vertical asymptote has indeed shifted. So if I want to find a y-intercept, I go 0 comma something. So that's going to give me -4 over 4. So I get -1. So 0, -1 is right there. So here's our graph. And it's supposed to be like this nice, easy, mellow curve, but... And then domain, well, negative infinity to 2, 2 to infinity. Extra points, I'm not going to play with it. Okay? All right, so now, vertical asymptote. How do I do this? What happens?
You have to square root -3.
Yeah, I got a negative square root.
That's ugly.
Vertical asymptote. X equals I root 3 plus or minus.
I don't miss this.
What does I root 3 even look like?
I don't even know.
Wow.
Look like
Somewhere up there. Somewhere there. All right, move on. Let's take a look at the horizontal asymptote. Do we have a horizontal asymptote? My degree on top and my degree on bottom. This is a 1, that's a 2. So my horizontal asymptote has to be y equals 0. So I do have this. Do I have any roots? No. Do I have a y-intercept? Maybe, I hope. So if I plug 0 in for my x, I get 8 over 3. That's 2 2/3.
How would you graph an I over 3? I mean, yeah, go 3.
So I have to change my 2 number lines. They can't be real numbers to real numbers. It has to be real to complex, in which we don't have. But I will tell you that this particular graph is going to look something like this. Okay? So if you look at it, does it go forever left and right?
Yeah.
Are there any values if I plug it in for x, I get 0 in the denominator? No. So my domain on this one is just negative to positive infinity. So this is kind of the trick one. Okay? If I plug values in, yeah, it's just a goofy graph.
Man, I guess I always thought chicks were for kids.
Yeah.
What?
I just go with it. All right.
Just go with it.
Same idea. Take a look. Same idea. Take a look. What do you think? Is this going to be screwed up because of my vertical asymptote? I get x equals plus or minus 2i. X equals plus or minus I root 2, I guess. So where does that really exist? Again, it's 2 real sets of real numbers that are number systems. Our horizontal asymptote degree on top is less than degree on bottom, so I get y equals 0. So I still do indeed get this.
So is it going to be like exactly the same as
It's going to be pretty doggone close. Roots, no. Y-intercept, plug 0 in. If I plug 0 in, I'm going to get 0 on top. So 0, 0. Is that right? 0, if I plug 0 in for x, duh. If I get 0 on top, it has to be 0 on bottom, 0, 0. So why do you think?
It's going to be the funky line thing.
Funky line thing. Let's go to my. I want to do a graphing calculator. Just to make sure I'm doing this right. Come on, T.I. Think about it.
So if you don't want to vertical asymptote, you just don't draw it.
Yeah, so let me I want to just show you what this graph is going to look like. So I have y equals 10x on top divided by x squared plus 2. There it is. So that's a good graph. So I drew the last graph incorrect too, so we're going to go back to it. So what do you notice about this, even though I have a horizontal asymptote? What's it doing?
It looks like it's flipped.
What is it doing right there?
Crossing the asymptote.
Yeah, it's crossing the asymptote. So let's go back. So this is going to, what's that going to look like this? Something like that. And I guess this one back here I goofed up. This one is actually going to cross there. So I don't know, some goofy. Maybe it crosses through there. Maybe it comes around here and makes a U-turn there. So yeah, and again, the domain, because we include this still, it still goes from negative to positive infinity. But how do you cross out an asymptote? So sometimes these with a goofy squared version in the denominator gives you a crossing of the x-axis, even though you have an asymptote there.
Nice.
Let's see, where are we going with these?
Yeah, we just have 2 more.
Okay. Bless you.
Isn't this x plus 3 and x minus 3 on the bottom?
On bottom, it would have factored to x minus 3,
Oh,
x
wait.
minus 3.
Yeah.
So let's just take a look what the graph's going to look like. I'm going to go clear.
We have a graph of factor like this.
Sure.
Really? I don't know. Because the whole thing is about graphing. So. That'd be chill, though.
That would be chill.
All right.
What's up, man?
This kid blowing the boy, don't do that.
So what goofy thing happened? So
The abyss.
why is that 3 existing right there? Well, I factor that denominator. So my vertical asymptote is going to happen. Oops. It's going to happen at x equals 3. So we have something here. The degree on top and the degree is less than the degree on bottom. So you have this. But then you basically have, well, you have this asymptote down. And then it comes right back up.
So, if we didn't have a graphing calculator, how would we get that graph on the test?
For you, Sam, I'd ask you to plug in 55 numbers.
Just for you, though.
So horizontal asymptote, yes, we do have it at y equals 0. But because we have this as a squared term, that gives us that goofy thing. Do we have roots? I mean, if I plug 0 in, I'd say I have this. So I get x equals 2. So I guess we have a root right there, kind of, that it does exist. Y-intercept, sure. Y-intercept, why not? It's going to give me 0, comma 2/9. And then domain 3 to infinity. Additional points? No. Except if you're Sam. Then you can do all the extra points you want. Did I get an extra? Alright. So, any thoughts?
Is it like similar to the other one then?
Yeah. X plus 2, which means I have this asymptote here. Degree on top and degree on bottom are different. And let's see, do we have anything goofy on that one? We have 2 minus x. So I think this one's going to do this. I think. So let's actually just graph it and see.
Opposite of this.
It's opposite because I have a positive x on top. I think. All right, so let's go back to my graph. Y equals, I get 2x minus 3 divided by x squared plus 4x.
You gotta get rid of the x squared. I mean, squared.
Plus 4. Graph. Dude, it's still an upside down. Oh my gosh.
It's on the other side of the y-axis, though.
It is on the other side. Oh. So again, like I'm glad that I record everything because obviously everything I do is incorrect. This is not like that. This is like that. This is like that. And these are just strangers.
So it just changes the place.
All right, so few things I'm thinking. Tomorrow's goofy, right?
Yeah.
Yeah.
We have periods 1 through 4 somehow.
Yeah, we had this class.
We have this class.
Long answer.
This is actually my only class. It's 1 through 4.
Yeah.
Yeah.
Dang it! If I didn't have this class, I wouldn't have to come to school. Okay.
Yo, I'm counting on someone else to write a happy note on the
You
board
just,
tomorrow.
yeah, you can say who's,
Yeah, you
just
can
get us a
cancel.
sub.
Yeah.
Not gonna do it. All right. So
have like one of those catch-up days.
Yeah.
we're gonna have 11H. That will be due.
Tomorrow.
You can't do it. If you can't circle it, it can't be over.
What's due Monday?
homework last night?
G.
Come on now.
And let's just do the evens.
Every other
All right. So 11H due Monday. What we'll do tomorrow, because it's kind of a fortunate day now, if some of you have a lot of stuff to make up, then maybe you should come in before school starts at 1 o'clock. It, 12 or whatever.
Who are you saying has a lot of stuff?
So I start with the friggin' gym again.
If
Sucks. Yeah.
but that's all I got planned, and then this will be due
So we're
on.
just gonna do a catch-up day?
Yeah, so we'll do a catch-up day. If you're all caught up because you're a rock star, you can do the Schoology review for the rational functions. If you already have done that, then heck, let's jump on that last capstone.
You're doing the ketchup. Is someone drinking the mustard?
That's mustard mayo.
The relish?
I leave early from class to look for my phone.
What'd I do?
I leave early from class to look for my phone.